Next up, we've got Alex Wade from Microsoft Research. He's a philosopher, librarian, technician, and he's going to talk about some of the interesting things that Microsoft has done with the idea of discovery in mind.
Thank you very much. Philosopher, librarian. I think I'll put that on my next business card. Excellent. So hopefully what I have here is going to complement some of the things that Simon just went through and maybe contradict him in one or two places, but hopefully for good reason. I come from a part of Microsoft that is not a profit center. Microsoft Research is very much a large computer science department. We have about 850 computer science PhDs who've come out of academia, who work for Microsoft in labs around the world. And really, they're here at Microsoft to continue the research that they were doing. They're not beholden at all to the product teams. They're really looking at core fundamental CS problems, but with an ear to what it is that Microsoft is going to be going into in the future and trying to lay some foundational work in that respect. And we do a lot of work with the product groups to really sort of understand what direction they are going. Traditionally, that has happened through things like tech transfer of prototype projects into the product teams, but it also increasingly is an IP portfolio of patents that the researchers are taking out. My specific group within Microsoft Research is about 50 people that is engaged in a lot of collaborative efforts with external researchers, with publishers, with computer science departments outside of Microsoft's forte. And we do that along a number of different subject areas. One of the projects that I'm specifically involved in right now and have been over the past 12 to 18 months is what started as a computer science research problem from a set of researchers in our Beijing lab. They were doing a lot of work in machine learning, in entity extraction, in information retrieval, and also looking at information visualization. And it's a project called Microsoft Academic Search. For those of you who are familiar with prior to Bing, there was something called Live Search at Microsoft, and Live Search actually took a fork of this code about 7 years ago and built in something that was called Live Search Academic. And then when the Bing team was formulated, they sort of scuttled a lot of the smaller efforts that were going on in the live space. It continued on during this time as a research project, and we're sort of sitting now, sort of moving it out of the researchers' hands, still providing a sandbox for the researchers to play in, but treating it much more like an official service from Microsoft. And specifically what Microsoft Academic Search is doing, in addition to being a search engine over the scholarly literature, is we attempt to carry forward this notion of entity extraction. So we index the papers, but then we dynamically create aggregations of these data around the author, around the journal, around an institution, around a conference. So you can, for example, go into this site and search a journal, and you'll see the list of publications that we have from that journal, but you'll also see some graph analysis, like who are the top authors, who are the most cited authors from that particular journal. How do those authors collaborate? And I'll sort of show some examples. I don't want this to be a demo. If you want a demo, come to our booth. We have one in the exhibit hall. But specifically, what we have been doing over the past 12 to 18 months since our team took this over is starting to collect a lot more information, exactly in the form that Simon was just talking about. How do readers discover content? And we've been doing this in partnership with the Bing organization, so we're actually looking at web scale logs and referrer logs. We've been doing focus groups, we've been talking to users, and trying to make some distinctions, not quite as granular as Simon was able to in the number of people that he surveyed, but looking specifically at the difference between novice or student researchers and more experienced researchers in their field. So I picked 3 topics here that I want to delve a little bit more deeply into that came out of some of these studies. And the first one is this notion of exploration, and not just moving away from this concept of just having a search box and 10 blue links. We heard repeatedly from both undergraduate novice researchers and experienced researchers that they weren't getting enough information to make decisions when they were faced with 10 blue links. And so a couple of quotes that came out of this is that I like the last one here. It's like when I'm searching for something that I already have knowledge about, I can use a search box. And specifically, if I'm looking for a known item, I want to get back to that author, or I want to get to this paper, a search box is great. People like that a lot. But if undergraduates repeatedly say, when I'm searching in a domain that I'm not exactly familiar with, I don't know the right terms. I don't know the terms of art. And there's a lot of groping around in the dark trying to figure out who the right people are, what the right topics are. There's a lot of iteration over search topics when they get into that space. This is a slide that actually comes from one of the folks who works on the Bing team. And so this is actually web scale content where some of these same problems are coming up. So 1 in 4 searches at web scale delivers, getting a little bit of feedback now, delivers a successful result. 42% of sessions require refinements to their search terms, and 44% of sessions last more than a day. I'll dive into that a little bit more. My colleague, Greg Tannenbaum, up here in the front row, is a huge fan of Bill Keane and Family Circus, so this is his slide in here. I'll just let this sink in for a second. But this is a good visual representation, I think, of the meandering path that researchers are going along in trying to look at some of the indicators along the way before they decide to read something, before they decide to click on a link. And the patterns here are slightly different between researchers and students, in that researchers typically understand the waymarkers along the way. They know who the right people are. They know what the important journals are. If they don't exactly know who this person is, they might know that they came from that department, and that department is really strong in this area, so I might go ahead and read that paper. Students, like I said, are groping around, and they don't know what the waymarkers are. And this is anecdotal, but one of the trends that we did see between the differences that we saw between undergraduate behavior and experienced researcher behavior is that experienced researchers tended to operate a little bit more like hoarders. If they came across a PDF that might be useful to them in the future, they would download it. They would add it to the reference management software. They would put it in a folder on their desktop. I found it. I might want to get back to it later. Undergraduates almost had a phobia of clicking on a PDF link. They would look at a lot of things before they decided what they wanted to click on to read. Because as soon as you clicked on it to read, there was this compulsion that, God, I downloaded that PDF, now I've got to read it. And so they were sort of sniffing around the outskirts of this quite a bit before they'd even click that button to look at it. So with respect to our own service here, just very briefly, we do provide this ability. There is a search box at the top. You can get the 10 blue links experience if you want to. But we also provide a browse interface into the experience here. So if I click on physics, I can see the subdomains of physics. I can see the top authors in physics. I can click into astrophysics. And then across the top, you see the types of things that we have in our system. So I've gone into astrophysics, and now I'm looking at the top journals. And top journals is based on our own graph analysis of what the interlinking and the citation patterns are by astrophysics journals to or astrophysics papers to other astrophysics papers. And so there's a browsability aspect to it, but more importantly than that is once you click on a publication, we're not taking you away from the site and saying, okay, that's it, you've got it now. We're trying to provide a little bit more context around the publication. So we will provide the abstract here. We'll provide a graph of what the citation history of it is. We will aggregate together both the links that we are getting from you guys, from the publisher's content, but then also copies of the paper that we may have found out on the web. We bring together citation context into this area. So where we're indexing the full text of the citing papers, we will strip out that citation context so you get a sense of what other papers are saying about this paper. Not just that they've cited it, but they said these things in the gray boxes down here at the bottom. And the author links at the top are also hyperlinked to the author profile. Oh, sorry, one more thing here. Settle that. Are hyperlinked to the author profile pages. So here's a case where we're aggregating the information together around one author. Now, this person didn't come to our site and said, create a profile for me. This is all, for the most part, automatically generated. So we actually piggyback on top of some of Bing's indexing. We go out, we find images, or in many cases, people come in and click the edit button, say, I want to add an image there. And the stuff over in the left nav here is then Again, graph analysis of saying who are the top people with whom Eric Lander has published papers, what conferences has he tended to publish at the most, what journals has he published in, and what are some keywords, some n-grams that we're extracting out of the abstracts or the full text of his publications. And if I click, another pop-up here, if I click into that author network, then we can also visualize some of these results as well. And so this becomes eye candy to a certain extent, but it's also actually a visual way of doing Boolean searching, because if I look at the line between Eric Lander and Manolis down here and click on it, I just did a Boolean search of show me all the publications that these two guys published together. And I click on that, and then I get a list of those publications. So topic number 2 is the path of least resistance. And this goes back to some of the stuff that Simon was talking about the relative importance of Google or of Bing, of web-scale search engines in the discovery process. And we certainly saw a heightened usage by undergraduates of search engines, but we did as well from experienced researchers, not necessarily as a discovery tool. Seldom did we see them using Bing or Google as I need to find a paper on some physics topic. But very often they did it as a way of saying, I have an item that I'm looking for, and I want to get to it. And even if they've used other abstracting and indexing services to find it, their first port of call will be a web search engine, because those are often the fastest ways of getting into that content. So, skip the slide here. But some of the reports that came out of the Ithaca report from a year or so ago reinforce some of these. And it's not an either-or situation. People are using ANI services and web search engine services in tandem as part of the same session. So here's a quick example. I got this paper title. I cut and pasted out of something else into a search engine, and it comes back, and I've got access to that item right here. And this is to reinforce the points that Mark was making at the beginning, where search engine optimization comes in. And it's very important to think about your content from an SEO perspective. One thing, so you see that the Mendeley article is showing up at the top of the list here. One thing that Mendeley does that IOP is not doing, for example, is putting some of the title words into the URL structure. It's actually a signal that both Bing and Google use as an indication of relative importance of a keyword or of a URL to a particular keyword query. It's not the only one, and this isn't this is more art than science to it, but there's some things that you can learn from this approach here. So get your content crawled, get it indexed. Make sure you're not inadvertently blocking web robots from being crawled by your site. I have conversations with publishers at least once a week where we're trying to index the content, and they've got a robots disallow statement in their robots.txt file. Sitemaps are hugely important. Sitemaps are a way of intelligently instructing the crawlers what parts of your site have the important content. And if you have a lot of content, there are mechanisms that you can use in the sitemaps protocol to say, here's the new stuff. You don't have to recrawl my entire site. Here's the stuff that has come out in our latest publication round. Navigational structure on your site is very important. URL structure on your site is important. So think logically about the hierarchical structure of your site. These are all clues that search engines use. Don't bury links to your site content in things like JavaScript or Silverlight or other things. Make sure that these can be explicitly crawled. And create compelling experiences for your users. Social media is one that's missing from this list, but social media signals are increasingly important in boosting citation rank. So make it so that people who are using social media can easily link back to your content, because as we index things like Twitter and Facebook, those become signals that boost the relevance. So Google has tools for you. Bing has tools for you. I chose to show the Bing one here, but there are webmaster tools that you can use to go and get a glimpse into what the big search engines know about your content. You can point us to your sitemaps if you have your sitemaps. you can get a sense of how often your content is showing up in search results, and you can get a sense of how often people are clicking on search results. So I picked one random graph here. This is a graph of how often people are clicking on search results in Bing and coming over to my academic search site. And the interesting patterns here is that this is the end of autumn quarter, and that's the holiday break from 2012, and that's the beginning of winter quarter. And those dips are the weekends. I didn't know that. I thought more students would be doing their work on the weekends and not during the week, but evidently keggers take priority. I guess things haven't changed that much. You can also drill into this and look at the actual keywords that people are using, where your content is showing up, the keywords that people are using when they're clicking through to your content. So be aware of the things that people are searching for, and that is another way that you can optimize your content to go from the terminology that people are using to how they will discover your content. Another very broad approach here is to start thinking about, well, a broad approach that Bing is taking, and we are starting to, but you should as well to the extent that you have search engines on your own site, is thinking about moving from a query-based approach, somebody typed something and did they get the content or not, and into more of a session, where session is a very broad concept of session. So this is an example from, a slightly contrived example from Bing, where they can look at an individual user's query history over the course of multiple days, and you get a much better insight into what it is that this person was trying to do. Maybe they're buying a dog, and yet they haven't actually said that, but there's a lot of clues in this particular approach when you look at these query sessions in aggregate. And rolling all of that up, at least half of the time people have these search sessions that last more than 30 minutes, and about 50% of the time, queries are people coming back to the search engine, continuing something that they started previous, the day before, a few days before. Another aspect is to start thinking about this evolution into a web of objects. This starts touching on some of the things that Tim O'Reilly was talking about in his keynote a couple of days ago. One thing that you should very seriously look at is schema.org. Schema.org is a great simple mechanism for marking up your HTML in a way that tells the search engines, and this is something that Microsoft and Google and Bing are all working, and Yahoo are all working on in tandem. It's at schema.org, and it provides you with the simple HTML level attributes where you say, this is a person, this is an email address, this is an event, this is a journal article, this is a book. So it's simple techniques that you can take advantage to enhance the moving your content from just being a title and then a bag of words. And you can see where both Bing and Google are heading in this direction, where over here in the first column you have the traditional algorithmic web results, but in the next column you start getting a thing. You start being able to address, I'm looking for something. I typed in Stephen Hawking, and this tells you who he is, where he was born, who he is married to, who his children are, what he's written. If you scroll down the screen, people who searched for him have also searched for Albert Einstein. You can click on that. And it's getting close to, can we answer your question without you having to click off the screen? In this particular instance, this data here is coming from a combination of Wikipedia and some other sources. But that stuff, that thing information that schema.org is enabling is starting to accrue in this direction. And then the last topic with a minute and a half left is tablets and applications. So I think we're concurrent with a mobile session right now, or maybe it was this morning, but do think about mobile as not just being phones, and do not think of mobile as having hit the saturation point by any means yet. Tablets are continuing to grow, and the projection is that even in the mobile space, that's going to approach 25 billion devices, more than double what it is today by the year 2021. So with that in mind, think beyond the browser. Don't think of a user sitting on their computer or even with their tablet using a browser as being the be-all, end-all way that they're going to be accessing your content. Think about touch. Think about gestures. Think about voice interaction. Think about social as a mechanism by which people are going to discover your content. One of the very frequent conversations I hear people having, I've heard some of them here in the hallways, is, should I build an app, a native app for the iPad right now, or should I be building responsive UI? There's a responsive UI session going on right now as well. We're sort of facing this question ourselves, and I think canonically, as I've had this conversation with a number of people, is build responsive first. The great thing about responsive is that it works across all devices. You don't have to anticipate what the screen size is going to be, and if next month Samsung comes out with a 9.5-inch tablet or a 3.75-inch tablet or whatever it's going to be next year, your responsive UI will automatically be catered to that, because responsive UI is doing exactly that. You may also want to have a native app for whatever the popular device du jour is, because those experiences can be more satisfying to the users. But building responsive gets you huge coverage. And the last thing I want to touch upon is don't think that you have to build all the entry points into your ecosystem. So we have an API on top of academic search. We invite the community to come and build new applications. One of my favorites is ReadCube. Plug for ReadCube if they're in the room. Go to the booth and get a demo of ReadCube. They're at the digital science booth. But ReadCube is a PDF library and PDF viewer, and they do a really nice job in enhanced PDF viewing, in that if you bring up a PDF, they will go and find all of the links to the cited items. I think whether or not they have a DOI, they do a really good job of that. So this is my library, but it's also a search engine tool. So it's an entry point into doing a search. So I can click on search, and you can see that they federate to Google Scholar, PubMed, and Microsoft Academic Search. I can do a search for it, and now my search results come up in that exact same tool. So now this is all running within the context of an Adobe Air application on my desktop. I've just done a search. I click on an item, and they will then run out secondary queries to see whether or not Google Scholar knows anything about this publication, or does Academic Search know about the references. And you can get this sort of iterative discovery layer across multiple searches at the same time. And they are getting into recommendations as well, so they learn your search history and say, hey, there's some other things that you might be interested in. And finally, social recommendations. So there's a number of sites that are coming up right now that are starting to build in recommendations based on what your friends, your peers, your colleagues are recommending as well. So with that, I won't walk through these, but think about the tools that people are using today, the way that especially this emerging generation of students who are going to be your researchers in a few years go about content discovery. Plan for the future so that you're not having to be reactive to every new device and trend that comes along, and get broad exposure. So thank you very much.